Mr. Shandelka, and this is 7.4, the tangent ratio. Hey, eyes up here, and or your sheet. The tangent ratio. If you attend every day, you have studied two trigonometric ratios, the sine ratio and the cosine ratio. The third one that's commonly used is the tangent ratio, abbreviated TAN, tan. What's that? The tangent ratio is the ratio of the side opposite an acute angle of a right triangle to the side adjacent. For an angle A, the ratio can be stated as follows. Tangent of angle A is the length of the opposite side over the length of the adjacent side. Now, opposite, we understand that word straight across. Adjacent means beside. Just remember that. And if you look up over on that poster, see tan theta is equal to opposite over adjacent. You might have opposites and adjacents labeled for a variety of different triangles. You can use that to assist yourself as you're doing these assignments. Now, let's take a look at this example here, because there's not a lot to it right now. So for this triangle ABC, ABC, the tangent of angle A can be stated as the opposite over adjacent, while the opposite is angle A. Okay, so that's good. Or side A, I mean, over the adjacent side. The one beside it, that's not the hypotenuse, is side C. So that's how you're going to do it, except that you're going to use numbers sometimes, and the letters will change. Let's take a look, and you're going to need a calculator with the sine and cosine buttons. And I see I'm fresh out, so some of you might have grabbed. If you have a phone, you can always turn it sideways, and it'll get larger, and it'll give you the sines and tangents and so on that you need. So let's just take a look here. Find the indicated side of each triangle. Now, right now you don't have to decide whether you use sine or cosine or tangent, but we're going to get to that point. Isaiah, you're not paying attention. Do pay attention. And you're going to always go through what angle are you interested in? Well, angle 38. I want to find side A, that's opposite. I have the adjacent side, that's 6.5. So you know you're going to use tangent, not just because it's this section, but because of the given information. So you're going to write down tan of 38 degrees. And you write it down right now. And then we're always going to write out the rule. Opposite over adjacent in this case. My ADJ is a little messy. I'm going to just rewrite that, but that's okay. So that now, taking a look here. The right angle is here, so this is the hypotenuse. We're not using the hypotenuse in the tangent ratio. But this is good to know that this is the hypotenuse, because this is how you know side beside A, angle A is 6.5. That's the adjacent side. That's what I want you to realize. This is adjacent. This is 38 degrees. The letter A is opposite side, right? And like I said, if you ever get confused, take a look at that poster there. It's got the sine, cosine, and tangent ratios written out of a variety of different triangle examples there to take a look at where opposites and adjacents. I advise you to write adjacent and opposite on your triangle at all times, and even hypotenuse, not that it's needed, but you should be aware where the hypotenuse is. I'm going to rewrite that just. Anyways, back to the problem at hand. Tangent of 38, this is where you use your calculator. You type in your 38 degrees and hit tan. I think that's how the phone calculators work. Miss Misha, do you have a tan button on yours?
Yes.
Is it on DEG, degree mode? Hit 38 tan, or I don't know if your calculator is where you hit tan first. You should get a decimal number. Accurately give me it to 3 decimals. You might involve rounding. Okay, what's that?
0.310.
Okay, I bet you your mode is different then. Tan of 38 degrees. Okay. And I will check mine. So then let me go into mine. Tan 38. There we go. 781. I'm not sure. Did you get 781 now? Because you should get 781. I'll take a look at yours later, Misha. Or does yours? I'm not sure what your entry thing is. 0.781. Now we can make that out of 1. Because this is like similar triangles. If you had a triangle where the adjacent side was 1, the opposite side would be 0.78. However, in this particular case, we're replacing. Instead of opposite, we're going to find out what is specific to this triangle. We're going to put the letter A there. That's what we're trying to find. And instead of adjacent, I want to do that. The adjacent side in this case is 6.5, so I'm going to put 6.5 down there. 6.5 centimeters, keep that in mind with your answer. Once you have that, you can cross multiply. 0.781 times 6.5 divided by 1. And once you have that, I'll give that to you. A is equal to 5.1 centimeters. Okay. Now, we'll try another one, the one right beside it. Let's take a look at this one. You know what? Doesn't necessarily use the tangent. Let's label this through though. If 51 is our angle, right? What is 9.3 compared to that angle? Is that opposite or adjacent? That's opposite. What is the Z? Hypotenuse or adjacent? Because it's across from the 90, it is hypotenuse across from the 90. And adjacent would be this side here, right beside the 51. Now, which one of the, and you can take a look always at the poster there, or you'll have it on a sheet of paper on a quiz. Which one involves the sides that we're interested in? Because we have, take a look, information about the hypotenuse and the opposite side. Which one of the ratios is that? Opposite? It's the sine one, not the sinner. I'm the sinner. Okay, so in this case, we're going to say the sine, S-I-N, of 51 degrees, we're using opposite over hypotenuse. You have to figure out what all the sides are, opposite, hypotenuse, and adjacent, and then choose which one of the three you might be using. So be careful, just because it's in the tangent section, now you can use any one of the three. Then you're going to use your calculator button. Let's go through this. You guys, what's that? Okay, sine of 51 has 3 decimals. So 3 decimal places. And you make it out of them. So I'm waiting for someone to give me the 51 degrees sine function. Depends which calculator you have, which order. 777. 7 Oaks, right? Isn't that the address? 777 Chrysler, 7 Oaks is 777 Albert Street. Anyways, point 7. Out of 1. We make it out of 1 just so it looks like the fraction we're used to. We say that in a similar triangle, the decimal 777 is like the opposite side. In our case, 9.3 is the measurement, meters. The 1 is like the hypotenuse. In our case, the letter Z in our triangle is the hypotenuse. Cross multiply 9.3 times 1. Divide by the lower. Divide by 0.77. You should have. I'll give you guys a second to try that. So 0.6. Ah, 11.969. Now, since the first given information was like 9.3, let's round 11.969. I'll put this down for a second here. Let's round that to 1/10, to 1 decimal spot. What is that properly rounded? Because that's a good answer, but it's not the best answer yet. What is the rounding? You always look, we're rounding to this spot, but what does the 6 tell us to do? Bump it up a notch, right? Now that turns it to 0. What does that do to the other parts of the number? 12.0. Okay, good. 12.0, and what's the unit in this one? Centimeters. Okay? You guys can do this stuff. Okay, so you're gonna have to just carefully look at some of these. So you're gonna go through on this assignment here and see, is this opposite, adjacent, or hypotenuse? Is this opposite, adjacent, or hypotenuse? What is this side, even though it's not used? Why is the label? Likewise here, label opposite, adjacent, or hypotenuse on all of these, and then decide which ratio you want to do. For question 2, the buildings. I'll give you a hint on this one here. You might want to jot down. 2 buildings are 18.5 meters apart. So these are like, we're gonna have the 2 buildings just drawn as like rectangles. So let's say one building's like this, one building's like this, but they're 18.5 meters apart. My drawing's getting messy already, so I'm going to make it a little larger just so I can draw it in there. When you're doing this one, that's the distance across, 18.5 meters apart from the 2 buildings. The angle of elevation from the top of one to the top of the other is 18 degrees. My drawing isn't quite like that, is it? But maybe I'll make it look a little more like 18 degrees. Okay, so this angle here, the angle of elevation is how much it goes up. This angle, we're told, is 18 degrees. The taller building is 15 meters tall. This one's a doozy. How tall is the shorter building? This one's a couple of steps. You're gonna have to use one of your ratios to find what this small distance is, how much taller the taller building is, and then subtract that from 15. There's a few steps to this one. The drawing, though, I thought I'd give you there to just get started. and then a ladder leaning against the house. We've done that drawing in the previous two sections, so you should probably be good on those. I will stop the recording.